All right, so the good news is it says solving equations, which you know how to do like so many different ways, right? You know how to solve addition and subtraction and multiplication and division equations. This year I told you about how to solve equations involving square roots, right? So how to solve that, if a number is being squared, to find the value of x and get x by itself, what did you always do with that? You took the square root of it, right? So the difference between today's problems and the ones that we've seen is that today's problems are already going to contain a radical. The problem itself has a radical sign in it. All right? And I'm hoping, like first hour too, they figured out immediately what to do. They just applied all their knowledge from solving equations in the first place and applied it to this. So what do you think, just from looking at this, you'd have to do first, Blake? Yep, add 8. So cancel out the constant. So you're writing this in your notes right now. You're going to cancel out the constant. And that's going to leave you with 2 square roots of x equals positive 8. So looking at that, what next? Yeah. Good. The next thing to do is divide by 2. Remember, our goal in all of this is to get that x by itself, and we're getting closer. All right. This is where you really stop and just think about it. So over here, this problem said, I have a number, I square it, and I get 49. What number am I? 7 or negative 7, right? What's that mean? Yeah, I have a number, I took the square root of it, and I got 4. What number am I? 16, okay? So here, so you know in your head, like that answer made sense to you. What would showing your work look like? Yeah. Yes. If it's already being taken the square root of, what's the opposite of taking the square root of? Squaring it. Do you remember me saying, like, when you have x plus 3 squared, and when you have a squared under a radical, they cancel each other out? So your work is going to be, all right, to square it. And that's where 16 comes from. So you undo this square root sign by squaring it. We're doing the backwards of this, guys, aren't we? All we're doing is the backwards of this. So now x is by itself, and it's 16. It's not positive or negative 16, right? It's just 16. Okay? So let's take a look at another one. Let's do 12 square roots of x minus 3 equals 0. So what do you think? Just like, I mean, literally it's the same type of problem, different numbers. So cancel out your constant. Go ahead and try that one.
Is our final on Monday, Tuesday?
Tuesday and Wednesday.
Are we going to, like, class review or something like that?
Monday. Monday will be an in-class review. Okay, and like Sophia says, we got to get one step closer to divide it. Okay, this one, you're going to have square root of x equals 1/4. So we're going to reduce. So it's almost like the exact problem as before, except instead of 4, it's 1/4. Okay, so but the important part is that you know that if it's already having the square root symbol around it, to undo that, or the inverse of that, is to square it. So the square root of x squared is x, and then this is 1/16. Got it? Okay, so that's the basis of it. Let's do a little bit more involved here. This time, let's take that and put it, so this time the x, the radical kind of went and extended. Before that negative 3 wasn't in it, but now that 7 is. So I still cancel out the constant, which is going to leave you with 4 times x minus square root of x minus 7 equals 16. Next step, divide by 4. Still have the square root of x minus 7. And this is so easy. What are you going to do now? take the square root of both sides, or I'm sorry, not take the square root of, it's already happening, square both sides. The square root of x minus 7 squared is just x minus 7. 4 squared is 16, and then we'll go all the way back to 5th grade or 6th grade where we have a one-step baby addition or subtraction equation, right? So now that everything's free of radicals, you just solve for x by adding 7, and x is 23. Okay. Now, all this is good except we're missing the most important part. And the most important part is you're going to want to make sure for these ones, not necessarily, it doesn't matter to check, but it's going to be hard to tell when to check and when not to. You're going to need to check your answer. And normally, that's something that, if you know you did the steps right, you know your answer's right. But there's going to be something that happens in the next example we do where you're going to do everything perfect, but one of your solutions isn't going to work. Okay, so let's just real quick, let's just make sure this works. The square root of 16 is 4. 4 times 2 is 8. And 8 minus 8 is 0. So that one is good. Okay, let's do this one. 23 in the x. 23 minus 7 is what? 16. The square root of 16 is 4. 4 times 4 is 16 plus 12 is 28. It checks. This one even checks because 12 times 1/4, or we said 1/16. So the square root of 1/16 is 1/4. 1/4 of 12 is 3. 3 minus 3 is 0. Okay. Now, here's the thing that I wanted you to notice for these. Those, you're going to have one problem like that on your final. So one like that, okay? You're also going to have one like this, though. The square root of 6 minus x equals x. And you're going to know right away why this is different. Because what happens when you square both sides? You get the dreaded x squared. And what does x squared mean? It means it's a quadratic. It means it's a parabola. It means that it can factor. And if it can't factor, then you complete the square. And if you can't complete the square, then you use the quadratic formula. But for right now, let's just look at what we deal with. We're dealing with a 6 minus x equaling x squared. Okay. So the first thing you're going to want to do is get everything on the same side, right? Get it in standard form. You're going to have one like this, okay? So x squared is positive right where it's at. So I don't want to move the x squared. I want to move the other thing. So here's the thing. Could you, since there's already 2 over here, could you subtract it from both sides and then just factor out the negative? Yeah. So it's kind of like you can put that over there, that then you'll have to factor the negative out. Or you could just subtract 6 and add x to both sides, right? So you're going to add x here, subtract 6 there. Do you see how I did that? I canceled them out. So because the person who wrote this book is so nice, they gave you one that factored. So you don't have to worry about that completing the square or that quadratic formula. So now I'm going to factor. And I factor this into an x and an x. Do you remember me saying when we first started factoring, I said, you guys better learn how to factor because you're going to be using it a lot. Can you imagine still not knowing how to factor right now? So minus 6 means a positive times a negative. 3 times 2 is 6. Put the 3 here, the 2 there. And because you're solving for x, you're looking for your zeros. So your zeros are negative 3 and positive 2. Or so you think. So now, because we're dealing with one of these x squareds, we have to check both of these to see if they work. And chances are only one of them is going to work. So you got to figure out which one of these is your answer. Okay? And to do that, you have to solve or plug it back in, right? Oops. So let's say that x is negative 3. -3, -3. Or let's say that x is 2. We're going to check them both. And there's a little bit of ambiguity here, and I think you're going to see what I mean. So 6 minus -3 is the same as 6 plus 3, which is 9, right? So I want to see if the square root of 9 equals -3. And I know what you're thinking. Yeah, it does, because it could be a positive or a negative. So usually, and here's what it's so hard to say this, and I'm not really sure why, but when you think of the square root of 9, you say 3, right? So we're dealing with just the positive square root for right now. So is the square root of 9 equal to -3? And I don't know a better way to explain that, but the square root of 9 is 3, and 3 does not equal -3. Okay, and you'll see why that is in a minute, because now look over here. The 6 minus 2 is 4, and the square root of 4 is 2, and does 2 equal 2? Yes. So for taking the square roots for this particular type of problem, I want you to take the positive square root only. So is the positive square root of 9 equal to that? No. So -3 is not a solution. The only solution that works is 2. So when you are taking your final exam, what do you think that they're going to put as your answer choices? They're going to put -3 and 2. And 90% of people are going to choose it because they got -3 and 2, right? But this is why it's so important to check. Because I looked at the one on your final, and there is one. This is called an extraneous solution. So it's solving an equation with an extraneous solution, meaning it's kind of an extra. It looks like it might work, but when you plug it back in, it doesn't work. So you can't count that. So your answer choices are going to be this. And then who knows what they'll put. So your answer choices, your correct answer is C. Even though it looks like it might be that, yeah. So let's try another one. Let's try the square root of 20 minus x equals x. So you go ahead and try that one. So here's how you know you're going to be dealing with the two solutions when you have an x by itself, right? Because when you go to square it, you have your x squared, and that is what creates the two solutions, right? So you're going to have your 20 minus x equaling x squared. You're going to want to get everything on the same side, so we're going to subtract 20 and add x, right? So add x, subtract 20. This, luckily, factors into x and an x, a positive and a negative. It's almost the same type of problem. 4 and 5 will give you one. So we'll put the 5 here and the 4 there. This will give me two solutions, but I have to check them both, right? So don't just assume that when you get that, because we're not talking about zeros, are we? We're talking about what, well, this particular one. I want to know what is x, okay? So I have the square root of 20 minus negative 5. Does that equal negative 5? We're talking positive only. Does that positive equal that negative? No. And you'll see why when you do this. 20 minus 4, does that equal 4? Does the square root of 16 equal positive 4? Yes. So your extraneous solution is the negative 5. Got it? So your only correct answer is 4. Okay? Yeah. Yeah, if this one is negative, probably that might be a good way to do it, but I would always still check it, plug it back in and check it to see, okay? So here's what I'm going to recommend you do.